So in my last class I was discussing that rotatory motion. Here so far we have completed that first phase of that rotatory motion. So first phase of that rotatory motion consists of that is a torque, parallax theorem, and again the perpendicular theorem, and moment of inertia. That is everything, and we have completed the theory and again the problems based on it. Now again we started that angular momentum and conservation of angular momentum, and thereafter it is the kinetic energy of a rolling body, and thereafter velocity of a rolling body along the smooth inclined plane. So that is inclined plane, and that is also over. Now we continue that the same theory. Now velocity is already over, and for that velocity what we have derived that those formulae, that is for the rolling body what we have taken, that is Vf, that is the velocity of the freely falling body from certain height h, and this is the theta of that inclination, and here it is the s is the length of that inclined plane, and Vf is equal to, and again next it is the Vs, that is velocity of that sliding body, and that will be equal to root 2gh. So this was the last class we derived it, and thereafter when you are coming to that rolling body, by application of that conservation of energy, we got this formula, that is a square root of 2gh by 1 plus k square by r square. This formula we derived it. That is the velocity of that rolling body. Vr is equal to square root of 2gh by 1 plus k square by r square. So it is already over. Now we are coming to that new one, that is acceleration of all this freely falling body, and again that sliding body and the rolling body. So acceleration. So when you are coming to that acceleration of that freely falling body is nothing but small g only. It is a small g only. When your body is allowed to fall down freely, it will be directed towards the center of earth, and it falls with an acceleration small g, and it is the first one is over. And the second one, when you are coming to this is a sliding body. For that sliding body, when it is sliding along that inclined plane, the acceleration will be g sin theta, because mg sin theta is the force which slides that body down the inclined plane. So that's why acceleration is the g sin theta. So now it is a g sin theta can be taken, and when you are coming to the third one is here acceleration of that rolling body. And for that we take the formula v square minus u square is equal to 2as to be taken. V square minus u square is equal to 2as. So in this case already we know that is v square is equal to 2gh by 1 plus k square by r square. So now it is a formula here, that is the acceleration of that velocity of that rolling body down that inclined plane, 2gh by 1 plus k square by r square. V square is here, and minus u square means it starts from rest, that's why u is taken as 0, and thereafter that is 2 acceleration of that rolling body that you have to find out, and yes, here we are getting that formula in terms of h. So that's why s is to be written in terms of h. Then how it is to be written? Now we are taking that formula sin theta. Sin theta is equal to, here it is h by s. Sin theta is equal to h by s. So that's why in place of that s, what we can write, h by sin theta. So h by sin theta to be taken. Now here that is 2h, that will be cancelled. Ar is equal to g sin theta by 1 plus k square by r square is that formula. That is acceleration of that rolling body is g sin theta by 1 plus k square by r square. So once again I explain it to you. So first of all, acceleration of that freely falling body is a small g, and acceleration of that sliding body is the g sin theta. And when you are taking this formula, v square minus u square is equal to 2as, and v square is equal to 2gh by 1 plus k square by r square, and minus 0 because it starts from rest, and thereafter 2a. A means that is the acceleration of the rolling body, and s is to be written in terms of that h. So sin theta is equal to, from this figure it is nothing but the h by sin theta. So sin theta is equal to h by s, and from that s can be replaced by h by sin theta. Now acceleration of that rolling body will be 2h will be cancelled, and g sin theta by 1 plus k square by r square. Now we can give the relation among them. So first of all, acceleration of that freely falling body is a maximum. Next one is acceleration of that sliding body, and thereafter the last one is the acceleration of that rolling body. This is the order. So now here acceleration of that freely falling body, it is a small g, and thereafter it is a g sin theta, and thereafter only it comes a g sin theta by 1 plus k square by r square. So far we have completed that velocity and acceleration of that rolling body. Now we are coming to that is a time taken. So when you are coming to this time taken, and for that we are taking that formula S is equal to ut plus half at square. S is equal to ut plus half at square, and first we discuss for that freely falling body. So it is a freely falling body, already accelerations are over. Now we are coming to this time taken. So for that time taken, that is a freely falling body, we are taking S is equal to ut plus half at square is there. S is equal to ut plus half at square. In that case, S can be taken as the h because it is a vertical displacement. Ut is the 0 and 1 by 2 acceleration of that freely falling body, and t square is here. So now here acceleration of that freely falling body, that can be taken S is equal to, once again I tell you, S is equal to ut plus half at square, and it is the, we are finding that acceleration of that freely falling body is the small g. So t is equal to square root of 2h by g. That is the time taken off by the freely falling body to reach the down the inclined plane. T is equal to root of 2h by g. So this the first one is over. Now we are coming to the for this sliding body, and for that sliding body again we take the same formula. So sliding body, in this case again we apply the same formula, S is equal to ut plus half at square, and here also that is S can be taken, here the S is that you have to convert that value of that S in terms of h. Already we know that S can be replaced by h by sin theta. So that's why this is taken as the h by sin theta is here, and ut is equal to 0 and 1 by 2, and acceleration of that sliding body is nothing but g sin theta. So that's why g sin theta is coming, and thereafter it is the t square. That is the time taken for the sliding body to reach the down the inclined plane. So it is the t square. Now this becomes, it is the t square is equal to, now it is a g sin theta 1 by sin theta root of 2h by g. That will be the formula for the t value, 1 by sin theta root of 2h by g. Now see that is S is equal to ut plus half at square, S is equal to h by sin theta, and ut is the 0 and 1 by 2, a is equal to g sin theta, and t square is here. And t square is equal to, that can be taken, g sin square theta is here, and thereafter cross multiplication 2h will be here, and t is equal to 1 by sin theta will come out. So that's why 1 by sin theta square root of 2h by g. So this is the time taken for the sliding body. This is the time taken for the sliding body. Now we are coming to that is the time taken for that rolling body. Again here also we apply the same formula, and that formula can be taken as usual. It is the time taken for that rolling body. We apply the same formula, S is equal to ut plus half at square is here, ut plus half at square, and S is equal to, as I already told you, it is the h by sin theta, and ut plus half at square means it is 0 and 1 by 2, and a for that rolling body is just now we have derived it, it is g sin theta by 1 plus k square by r square, g sin theta by 1 plus k square by r square, and it is t square will be as usual. And from that when you are taking that t square, so first of all it is the g sin square theta is there, so t square, now it is the 2h, and after that it is a cross multiplication is the 1 plus k square by r square is here, and again thereafter it is a 2h and 1 plus k square by r square, and by g sin square theta, g sin square theta is here. And when you are coming to this portion, that is 2h by g, t is equal to square root of 1 by sin theta will be here, and thereafter it is the square root of 2h by g of 1 plus k square by r square is that formula. So it is 1 by sin theta square root of 2h by g, and again even inside the root that is 1 plus k square by r square, 1 plus k square by r square is also there. Now you can take that time taken for that freely falling body is root of 2h by g, and time taken for that sliding body it will be 1 by sin theta square root of 2h by g, and thereafter time taken for that rolling body it is a 1 by sin theta square root of 2h by g of 1 plus k square by r square. And in all these cases, first what we have to understand, that time taken for the freely falling body will be minimum. Time taken for that freely falling body will be minimum. So that's why time taken for the freely falling body less than time taken for that sliding body, and less than time taken for that rolling body. So time taken for that rolling body, time taken for that freely falling body, it is a square root of 2h by g, and here it is a 1 by sine theta square root of 2h by g, and here also definitely it is for the sliding body, it will take more time than that of the freely falling body. It will take more time than that of the freely falling body. Why? Because here the theta cannot be in the 90 degrees, it will be less than 90 degrees. So in that case, now if at all that sine theta is taken less than 90 degrees, this time taken for the sliding body will be more than that of that freely falling body. Next one is for the rolling body, and it will be that is more than that of the sliding body, 1 by sine theta square root of 2h by g of 1 plus k square by r square. Now so far what we have completed in the second phase of the rotatory motion, here we have completed that the first one is here angular momentum, and thereafter conservation of angular momentum, and thereafter applications of angular momentum, next energy of a rolling body, and thereafter it is the velocity and time taken and acceleration of that rolling body. In all these three cases are completed, and we have taken that relation among them for the freely falling body and for the sliding body and for that rolling body also. Now we are coming to these problems. So problems are based on all these concepts. So problems are based on all these concepts. In this case, as I already told you in the previous class, in my previous class also, these problems are not meant for advanced level test. These are meant for the main test as well as for these useful for NEET students also. So don't get confused, these are the advanced level test problems. These are the main test only. So these are applicable for this, useful for the main test only. First we are coming to this. A sphere rolls without slipping on an inclined plane of inclination theta. That's meaning is it is a rolling body. A sphere rolls. So now it is rolling, this is the theta is here, and a sphere rolls without slipping on an inclined plane of inclination theta. Then what is the minimum value of mu so that the sphere rolls without slipping?